Hi everyone, my name is Joe Fitzpatrick and I am based in Limerick City in Ireland, and I'm delighted to be here at ICAD 2021. I was in the student think tank in the 2019 ICAD presenting my PhD research, and this is really off the back of this paper presentation. So the title of my research is a Perceptually Congruent Sonification web guide, and what it looks at is two kind of questions. How do phenomena of auditory perception affect sonification design, and can the principles of auditory scene analysis be applied to make sonification applications more robust? And we really wanted to make this new research accessible to everybody through the use of a web guide. So not just to experts in auditory perception or practitioners of sonification, but also to data scientists who may not be familiar with either. The research is all based off the Perceptually Congruent Sonification framework, which is the focus of my PhD. And what it looked at is the really important and relevant stuff to sonification. So rather than just also looking at frequency, timbre, time, loudness, and space, which we do, we also look at auditory scene analysis and the core principle stream segregation, which refers to how various auditory streams might merge together when they are close in frequency, timbre, space, or time. And we basically determined that they were the core determinants of that. So we kind of went about linking these to the sonification mapping pairs and trying to outline it in a clear and really comprehensive and concise way through the web guide, and also using audiovisual interactions. When we're talking about auditory perception, we know that the core determinants are these kind of frequency, time, timbre, space, and loudness. So we were looking at frequency selectivity, pitch discrimination, loudness perception, the equal loudness level contours, spatial acuity, and temporal resolution. And also we're looking at a little bit of the working memory and attention mechanisms involved in auditory perception. However, that was more in collaboration with other members of the research center. And here are some examples of how these apply to sonification. Just a few examples of what's relevant and why would we care about some of this stuff when we're designing an application. So I won't go through them all, but I will leave them up just so that people can see and maybe pause it and go over some of them. And in terms of auditory scene analysis, we were looking at the streaming effect, i.e. stream segregation, exclusive allocation, where if we perceptually place one object in a group of similar objects, it can't then be allocated somewhere else, and as well as perceived continuity, where intermittent sounds being perceived as continuous when connected by bursts of louder or more distracting sounds. And this is stuff all that Bregman has tied to visual perception. So it was really about kind of applying this to sonification, and the way we'd really kind of go about that would be perceiving a sonification application or an auditory display as a virtual auditory scene. And again, we identified that the core phenomenon at play here is stream segregation, i.e. either the segregation or the merging based on similarities in auditory attributes. And the determinants that we identified here were the ones we were looking at in auditory perception, which are frequency, timbre, time, space, and loudness. So they were really dictating how things were being allocated into groups. And again, we also looked at some attention mechanisms and working memory models as well. So without further ado, I want to just quickly go through the web guide, and we'll have a look at some examples. Okay, so this is really where we arrive on the website. This is the home screen, and it quickly introduces the Perceptually Congruent Sonification framework, as well as a little bit of background on sonification methodologies. And this is the kind of generic visual model of sonification done with UML, which is just a handy tool really for outlining some theoretical models, because it lets you show dependency and composition of and so on. So really this is just a kind of introduction to sonification and breaking down an auditory display into its different types of mappings. This is then followed by a breakdown of stream segregation, which we've identified as really a core or most important part of auditory scene analysis when talking about sonification. So we have stream segregation and its attributes broken down into a function of sorts, this allocation function, which has its composition or dependency on these auditory attributes. Okay, so the dotted line here is really talking about dependency, where the arrow is dotted as well. It's talking about dependency. So allocation is dependent on spatial location, frequency, content, temporal characteristics, and loudness. Okay, so we're just really presenting the framework itself first, to show what the background is on this research before introducing the guidelines themselves. And I suppose the more important thing to look at here are the actual determinants of allocation, but how do they apply to auditory mappings? So it's about joining the two together and showing which of the mappings are dependent on which determinants of allocation. Obviously spatial location, spatial mapping are going to be linked, and the same with loudness. However, most sonification applications and auditory displays are going to be dependent on understanding these modules here, frequency, content, and temporal characteristics, simply because frequency, timbre, and time, they all have a relationship and are extremely relevant in all applications, whether it's parameter mapping sonification or model-based sonification or any other types of sonification. So the guidelines themselves are broken down pretty much into those categories. And it gives a brief explanation about these and some of the audiovisual interactions here. So, for example, the frequency and spectral content is probably the most content heavy, with visualizations and kind of conclusions drawn into them throughout as well. And this is where you find pretty much all of the auditory audiovisual interactions here. But we also do have the other modules here, loudness. Going through the equal loudness contour levels, there's a little bit of overlap between that and frequency, as you'd expect. Spatial location. So we're talking about spatial stream segregation, binaural fusion, and as well as multimodal applications. And then it also includes a tab here for all the audiovisual interactions. Okay, so just to go through some of the audiovisual interactions, they're all really found in the frequency and spectral content tab in context here, and they all have kind of descriptions on how to use them and what to look out for, really, without leading it too much. So we'll just go through maybe the presentation rates one, where if you increase the presentation rate, what's the effect on our ability to identify the sequence as well as identify groupings, and the groupings start to become apparent when we increase the tempo. Okay, so they generally pop out and open here. This is all done using the Web Audio API, and you can see the x-axis here is controlling the frequency and the y-axis is controlling the tempo. Okay, so we'll start off with looping them, and again there's instructions here on how to use this. Okay, so we'll start with a relatively low frequency route and a low tempo. Okay, so we can generally identify the sequence there, and there's no major groupings maybe apparent. Again, this is just my experience of it. And if we bring up the tempo, then okay, so obviously the sequence becomes slightly harder, and for me it starts to identify maybe a high-low grouping here, which has been linked to then the research as well. So it's a little bit out of context here, but once you're in the actual module itself, it makes a little bit more sense. So this is just one example. I won't have time to go through all of them, but they are all on sonification.ie so that you can go through them yourselves. Okay, lastly, I just want to quickly go through some of the preliminary feedback we got for the survey. That is still available on the site. We posed 2 statements and asked people to disagree or agree with them. The first one was perceptual evaluations of all practical non-artistic auditory displays and sonification applications are necessary. And we got quite a strong response to that, saying everyone was agreeing. The next statement was there is sufficient information regarding human auditory perception in sonification literature. And we had a lot of people agreeing here and some people disagreeing. So this is really just to gauge people's responses and how people are thinking about auditory perception in sonification. The next part of the survey was really just looking at the web guide itself. So another Likert, but this time just asking for basically how accessible or easy to navigate is the web guide. We got a strong response, strong positive response there. How relevant is the written content and figures? And again, another strong response here. So people were happy with what was in the guide and that was relevant and that was easy to understand. And then we asked about the audiovisual interactions specifically, and they were less easy to use, but this is to be expected as it requires a lot more interaction and involvement. So there's room to improve there for sure. And again, asked the other question about how relevant are the interactions, and again we got a good response there. So in the context that the audio visual interactions are placed, they seem to make sense to people. Okay, so future work, we're really just looking to expand the overall guide's contents and acquire more critical feedback, which we're desperately missing at the moment, and including some feedback on accessibility as well as for blind and visually impaired. We're also going to do a systematic review of perceptual considerations and references that are apparent in contemporary sonification works and publications to try and get a better idea about how auditory perception is being used in the design stages as it is. And also looking for further feedback from practitioners to gauge their use of it and importance, how relevant they actually think it is. And lastly, looking at how the perceptually congruent sonification framework itself might be applicable in standards. So when we're designing standards, is this information relevant? So that's something we'll be exploring as well. Okay, so brilliant. Thanks everybody for your attention. I'm absolutely delighted to be here, and I'm looking forward to everybody's presentations. Thank you very much.
Thank you, Joe. This is a really invaluable educational resource. And it looks really great and quite comprehensive. Stephen has a question. Any plan for sonification design building tool based on the PerCS guide? How do you intend this to be sounded?
Yeah, so I think one of the feedback that we got, I mean, it wasn't a lot of feedback, but some of the feedback we got was about could we include this in auditory scene synthesis. So I suppose it would be great if we could bring it into a tool at the very beginning. So if they have something, like any of the assessment or evaluation tools or any developing tools, something like Max, there are objects in Max, for example, or a super collider that do implement auditory perception research, and they're built off it completely. Not in my head in the moment, but it's on sonification.ie, which tools those are. So yeah, it'd be great if we could bring it into that, where you have that background research being built into the tools. So yeah, it's in terms of, I'm not a programmer myself, so we're looking to kind of expand. Our research center is expanding, so we're trying to get people in who would be able to facilitate that. SoniPy would be a kind of example of that, where it would be a great tool that we could use to, implement that, where you have tools developed using SoniPy. I think I'm saying it right, but yeah, it'd be something like that. So it'd be worth looking into.
Excellent.
Yeah, at the moment, yeah, it's really just theoretical, but it'd be great to see if it could be implemented, even that, or standards or something else.
Prithvi has a question as well. How much individual variability is typically observed in the way listeners segregate streams within a single stimulus for sonification guideline creation purposes? Yeah, for standards, of course.
Yes. This is the thing, in terms of the research that I've looked at, they look at very specific use cases. So it's a really brilliant question. And I think, yeah, if we could get some more studies on it, but in terms of where there's a significant amount of consistency between different individuals, I think there is a line there somewhere. Now, exactly how consistent that is, I'm not 100% sure, to be honest. And I think it's a good point, because we can do all this work and all this research, but if it means that there isn't really a consistent way that we do perceive scenes, because it's not exactly the same as, we have the equal loudness level contours, and there are huge amounts of research behind that, and it is quite consistent. But with the auditory scene analysis, the way that we perceive perceptually organize things in our auditory cortex, it could be different for some people. So there are definitely limitations that some people might have that aren't, as easily identifiable as the equal loudness level contours. However, having an idea of how we do actually perceptually create these scenes in our mind, I think it's a good starting point, at least.
And I guess since you were looking for critical feedback, one piece of not criticism, but like critical piece of feedback is a question I would pose is, to me, there's really a difference between stream segregation, which of course is important perceptually, but the larger issue of sense making, like how do you comprehend information comprehending information is a different and more general and more complex question than stream segregation, even though even in stream segregation, just as you said, there are variability, because it has to do with the brain, and so it has to do with the complexity of each individual in a sense. But sense making is something that I would love to see referenced in this web in this educational resource, because I think it's really important for anyone making sonifications to like have in mind also what's the intention. Like, is this a researcher who's going to be, you know, deriving very specific scientific information? Is it, you know, for some other effect? And if I don't know if you want to say something really briefly, but the rest of this bigger discussion will have to be in Q&A room too.
Yeah, no, we can do it then for sure. But yeah, I think that we do touch on attention mechanisms, which I think is what maybe a similar kind of thing we're referring to of the sense making, how we perceive auditory objects. And I think there was a few people who spoke about it as well. But that would be the closest we've got to it. And yeah, I suppose it definitely needs more work on it as well to be incorporated.
Yeah, I mean, I think it would just be a great for that aspect to sort of expand
Definitely.
a bit.
Yeah, there's a way to
All
go
right,
from here.
thank you.
Thank you.
Thank you so much. This is really, I'm very excited to check out this resource. And were you able to post the link? Yes, you were. Yeah.
Yeah.
So thank you for that.